let's start today. Let's see what we got. Why does it automatically log me? Oh, because I restarted, that's why. We'll see what we have today. There are some robots and factories on x-axis. Let me grab a pen and paper to my pen. Here it is. So what do we have? We have an x-axis. There are some robots on x-axis. You are given an integer array robots array. Here are the position of the ith robot. So robot 0, robot 1. You're also given a 2D array, 2D integer array factory. So factory is something, let's say position and limit, and factory where position and limit indicates the position is where factory j indicates that position is the position factory. And so this factory at p location can fix l amount of robots, right? The position of each robot, so positions are unique. Position of each factory is also unique. Note that a robot can be in the initially all the robots are initially broken. They keep moving in one direction. The direction could be negative or positive direction. When a robot reaches a factory that did not, the factory repairs the robot and it stops moving. At any point you can set the initial direction of minimize the total distance traveled by all robots. Turn the minimum total distance traveled by all robots. Two robots. I'm thinking of this as another dynamic programming problem, and if two robots move in the same direction, they will never collide. If they meet at some point, they do not collide. They cross each other. Collision is not a factor. If a robot passes by a factory that it crosses it as if it does not exist. If the robot moves from So let's see an example. We have a robot at 0, factory 2 has a limit of 2, factory 6 has a limit of 2. The first position robot moves in the positive direction. It will be repaired at the first factory. The third robot, the limit of the first traveled is 2 minus 0 plus 4 minus 2 plus 2 minus 4 plus x-axis can also be negative. At position 1 moves in the negative direction. We repair. So what should we do for dynamic programming? We should find the minimum distance of robot from a factory. How do I think about this? I struggle with dynamic for sure because I don't know how do I initially bring about the structure. So there are some robots. So for each robot, or if I compute something, can we draw, right? So I have a line, right? X-axis. Oh, what's happening here? So I have a line. So let's say these are the robots, these are factories, another robot. So for each robot, one robot and a robot. So robot, what should I have? We need to find the minimum distance from robot position. So we should have dp of robot position to the factory position should be the minimum. But we could either go to for example, this robot can go to this side or go here. We also need to keep the limit count. So robot, factory, and limit. So I'm thinking of it. So dynamic problem of robot, factory bracket exists to minimum distance equal to distance. What other constraints? Robot dot length. We could have up to 100 robots and factory. There's only 2 factories. Factory dot length equals to 2. So let's say there were more robots. So we go through how will we do this? Everything is unique. Oh, what do I want here? How do I think about this? So for each robot, I need to check the closest factory with limits and then add that distance to total. So how do we loop? So we are given the positions, right? If I'm given the robot I is the position of the ith robot, and so given a 2D array factory or factory j is the position. So do I grab the So if I do something like let me loop through for each robot. So how do I do this? For each robot, So for a robot in the array, check the position of the factory. How do I do this? So if I'm given the robot array is, let me go down here, example, let me take the third example, this example, example 1, I'm given robot is 0, 4 and 6, and that factory is for 2, 2 and 6. So what do I do? So for robot 0, for in robots I check. How will I do this? This is annoying. Okay, that's spaced out. So maybe I create a common list and map everything on a list, but we might not actually need that. So I don't know, how do I even think about this is. Let's see some hints. If I sort the robots and factories by their positions, each factory should repair some segment of robot. Find the minimum total distance repair first. I robots with first J factories. So let me sort TJ robot, sort robot and factories by their position. So if I'm given a list of integers, how will I sort a list? I'm not sure how do I. Arrays, can I do array by sort, or do I go through the whole list? I don't know how to do this one. Let's try to learn. I think we need dynamic programming here, but I just never know how to start. What I think is we need to find, I think we need is for each robot and the closest factory, if limit exists, find the minimum distance. All this animals because robots can cross out everything and factories. What position, comma limit is like example 5 2 and 10 1 becomes 5 5. Match robot the factory slot 1 to 1 matching the factory slot. So let's think what's happening here. So initially we sort both the arrays in slots. Skip the slot. Understood up till this part. Understood up till step 3. Play in the rest. I'll slow down and make sure step 4 plus dp click because. So ij means for a robot that minimum cost dpij is equal to minimum cost to fix robots using first j factories. Now focus what happens at I and j. We are looking at robot of I minus 1 and j slot. We have two choices. Choice 1, don't use the slot. Choice 2, use the slot. The slot completely. Choice 2 is, let's say I have robots in one factory. After expansion slots are 2 and 5. Building we compute dp I and j. So for robot I, j1, j is 1. Option 1, dp skip. Option 2, we do or to option 1 we skip. Option 2 is dp. Option dp of 0 and 1. 0. Still having trouble understanding. So once we compute the dp table for robot 1 and slot 2. Option 1, if we don't have any slots, so we have one robot but no slot, will be infinity, or we take the robot. So we have robot I minus 1 plus j minus 1 plus 1 minus 2 equals to 1. So dp of slot j equals to 2, which will be 5. Slot 5. No, dp of 1 and 1, either we skip. If we skip by j, how do we get this? So we are at robot 1 slot 5, compute dp, so distance is 1, so okay, so we computed the dp of 1 and 1 is 1. If we skip 0 plus 2 minus 1, and 0. So I have 1 3 and 6. So factories and chairs, factory. Yes, so slot is 2. And the problem becomes robot is 1, 3 and selection slot are 2. You need to match them in order. So what does DPIJ even means? So it means the minimum distance using the first chairs. What's the best one? Focusing zoom into I equals to 1, robot 1. We are asking for robot 1 slot equals. So we are asking for robot 1. Should I use chair number 5 or ignore it? Option 1. If we skip, meaning this chair looks, return to the previous answer. Robot 1 to chair 2, the distance is 1. Skipping gives us cost 1. So if we use the chair, let me try setting the robot on chair. Distance is 4. Final. Super simple way to think when you see any other equipment example to lock it in. So I have robot 10 slot 2 and 9. At slot 9, two choices whether you use slot. So let's first sort the array. So where is my thing? So first sort the arrays. First do arrays dot sort what robot, and then I will do arrays dot sort teacher array factory where a comma b a dot length minus b dot length. So to sort the list, we do collections dot sort robot and arrays dot sort factory a comma b where a bracket 0 minus b bracket 0. Once I have this, I need to construct. So let me have a list that takes in a fact list of teacher or slots equals to new list. So what we do for teacher and what are we doing? Factory we are doing integer position equals to factory of 0. Teacher limit equals to factory bracket 1, and then for once we have limit ranges for integer I equals to 0 less than limit plus plus. We're doing slots dot add position. So we are adding position that many times, right? So once we have added that, we need integer n equals to robot dot I. Do I have a method for that? Yeah, integer m equals to factory dot size. I want to have long programming equals to new long of n minus 1 bracket m minus 1. Oh, plus 1, sorry, why am I adding minus m plus 1? So we do for base case for equals to 0, I must be equals to 1, must be less than. What am I doing here? I must be less than equal to n I plus plus dp of 0, dp of for each robot, and dp of I bracket 0 for each robot if there is no factory divided by 2. So what we are doing is for teacher I equals to 0, I must be less than I equals to, we will start with 1, right? I equals to 1, I must be less than n and I plus plus. Then we check for j equals to 1, j equals to less than equal to plus plus dp of I and j minus 1, and long cost equals to, what is the cost equals to, sorry, get mat dot absolute of slot dot this one minus slot, I think that's what I slots of dot get j minus 1, and then primary of I and j equals to j comma 1 bracket j minus 1 of this plus cost. What are we returning? Dynamic programming of, there is a typo here, this method min of still don't stack. Okay, so the slot, so right here we are skipping the slot, if we take up the slot, we are not doing, we are just in slot, using slot j means it's consumed. Okay, that is the, so this actually means is we are going one position back, so that, okay, just a little bit, still need to fork on these problems, man. I'll see you tomorrow. I don't think it was a good day for me today, but I did what I could.